All right, so what equation are we using here for number one?
The big one.
The big one, what's it called?
P1 over T.
Yeah, what's that called?
I don't know.
Boyles, Charles, Lusac. Combined gas law, right. Okay. Okay. Yes. P1 V1 over T1 equals P2 V2 over T2. What is P1? 0.70. What's V1? 75.0. What's T1? 300. Okay. What's P2? 1. How come it's not 101.3? Standard pressure is 101.3.
It's an ATM.
Right. Atmosphere is ATM, so that means we keep the same unit, 1 here. We don't put 101.3, that's a KPA, it's kilopascal. All right, V2 is X. What's T2? 273. Cross multiply, and then we divide by 300, and we get 47.7?
Yeah.
Yes, 47.7 milliliters. Boy, I didn't tell you how to round it. So 47.7 milliliters, but if you were rounding to proper number of sig figs, let's say this had a decimal point here. How many would we round to? Given this problem right here on the board. 2. 2 here, 3 there, 2 there, 3 there, 3 there. So 2 would be the lowest. So technically, if this was following the rules, it would be 48. 48 milliliters. No. On the Regents, it will ask you, or tell you, I should say. If it's a short answer, it'll say round your answer to the proper number of sig figs. This one was just more practice for you to use the equation, solve it, because on your test tomorrow you have a couple of these, and I think one of them is short answer, one of them is multiple choice. So if it's short answer, then it will tell you about significant figures. All right, 2. What equation do we use? Q equals MHF, right? Because melting is the heat of fusion. That means the same thing. How come we can't use delta T? There's only one temp. You don't have a change. Good. So Q equals MHF. So 25.5 times 334. Right. 334 times 25.5. What is it? 8,517 joules. 8,517 joules. Very good. Very good.
Nice.
Okay. Take out your notes. We are done with that. So feel free to put that somewhere else so you're not going to doodle on it. Yes, sir.
Can I borrow one of the balances?
You can. You got. How about the one under the goggle cabinet? That'll work. Are we collect? Oh yeah, we can put them back. Let's just put them back. I know. Let's put them back, please.
Oh, thanks, Nate.
Oh, you need that. You need that. Calculators, keep them. Keep
Play
them.
softball, not baseball.
Olivia, no glasses today. You don't have contact? You just can't see?
Bro, you took my tissue and I'm never getting it back in my bag. I did too. Here,
Come on, let's go. Let's go. Take out table I, please, and your notes. Table I and your notes.
I'm so generous. I just took it so mad.
What is happening?
I flipped out. She's being rude. I'm always kind of the tissue. There's a garbage can right there.
Okay, next time Amber will put them all away.
I wasn't even a part of that. Don't blame me. No.
I'm not blaming you, I'm just saying electing you.
No.
Hey.
All right.
I'm a victim.
Now, table I. Go to table I, please. Now, in our notes, we are going to do a couple practice problems to get you ready for doing this sheet, which I just gave you. So keep this out. Keep this sheet out. The one I just gave you due Friday. Okay. If you go to table I, do you need another one? All right. Okay. Let's go. Thanks for your help, Caitlin. All right. Now, if you look at the right side of table I, what does the value of delta H tell us? What does that number tell us? If it's endothermic or exothermic. If it's endothermic, it means it's absorbing energy, which is positive. Good. If it's a negative number, it's exo, releasing heat. Very good. Okay. So the concept here, though, is we need to be able to figure out how many moles are in each reaction, and then how that mole number can change and how that affects your delta H. So let's get an example here. Did I do one with you yesterday?
Yeah.
She said yes, she said no.
Yes.
Yes, okay. Can you tell me which one we used yesterday? What reaction? I only did one, I think.
2C plus 2H.
2C solid plus... Oh yeah, actually we didn't solve it. I just gave you the problem, right?
Yeah.
Okay, so 2C solid plus H2 gas, 2H2 gas yields C2H4.
Yeah.
All right, and then my question was calculate the value of delta H if, I forget,
It was if 1 mole.
if 1 mole of carbon reacts. Okay, 1 mole of carbon reacts. All right, so how many moles of carbon do we have on the reactant side here? 2. That number tells us how many moles. What's a mole?
Number of particles.
Right, what is that number?
The big number.
6.02 times 10 to the 23rd, right. So after this problem, I will show you the video, I have it set. But a mole is the number of particles, so just keep that in mind. But we have 2 moles of carbon. How many moles of hydrogen? 2. How many moles of C2H4? 1. I don't like how I wrote that. That looks weird. So, yeah, how do we know there's a 1 there? Because there's nothing there. If you see nothing, there's a 1. Can't be 0. Why? Because that's nothing, right? So, what's the mole ratio? Jake, what's the mole ratio of carbon to C2H4? Try again. How many moles of carbon do we have?
2.
How many moles of that do we have? What's the mole ratio then? 2 to 1. It's a 2 to 1 ratio. Andrew, what's the mole ratio between hydrogen and C2H4? 2 to 1, right? Okay. Caitlin, what's the mole ratio between carbon and hydrogen? 2 to 2. Or 1 to 1. Very good. So how do we find mole ratios?
Coefficient.
Look at the coefficient. Look at the number in front. Amber, what's the mole ratio from C2H4 to H2?
1, 2. I don't know. 1 to 2.
Let's try again. What number's here? 1. What number's here?
2.
So what's the ratio? 1 to 2.
Yeah.
Right. 1 to 2. So I'm trying to make it very simple for everybody, because if you can't understand the simple ones, the hard ones will get more confusing. Who's confused about the mole ratio? No one's going to raise their hand now. Okay.
Wait, ask me that question.
No. Okay.
Well, then I can't answer.
What is the value of delta H for this reaction? Find it on table I. I don't know if we already did that.
Oh, we done here.
52.
You got it?
Yeah, it's me.
4.
5, 5, 6, 1 to go.
52.4.
No, it's
What are you talking about?
Oh, wait, that's the wrong one. It's
52.4.
Okay. So over here, I'm going to write delta H equals 52.4 kilojoules. Now, on the table I, next to the delta H, is there a little RXN? No?
No.
Sometimes you're going to see this, a little RXN subscript. What does that stand for? RXN. What do you think?
The guy that made this 3 favorite letters of the alphabet.
No.
Oh my god.
Try and sound it out.
Rickson.
Reaction.
Reaction, thank you. So delta H, RXN, stands for reaction, okay? Delta H reaction, heat of reaction. That's what that stands for. You're going to need to know that if you look at this sheet right here. Go to number 1. Okay? If you look underneath the equation, it says calculate the value of delta H Rxn. That means heat of reaction. So, heat of reaction is 52.4. It's from table I. Okay, stay with me. Look up here. 2 moles of carbon. First of all, is that endo or exo? What's that mean? Absorb, enter, put in, something like that. So 2 moles of carbon needs 52.4 kilojoules of heat in order for it to react. 2 moles of hydrogen need 52.4 kilojoules in order to react. 1 mole of C2H4 will be produced, but it needs 52.4 kilojoules to be absorbed in the reaction before it can be produced. So 2 moles needs 52.4, 2 moles needs 52.4, and 1 mole needs 52.4. What I'm trying to get you to see is that the moles and the heat are related. So, if you read this question, or the statement, if we have a 1 here instead of 2, that changes the whole reaction. It also changes the heat. Let me give you an example. How many tires does a car need? 4. What if you have 2 cars? 8 tires. What if you have 10 cars? 40 tires.
Yeah, I added 3.
What if you have 100 cars?
400.
400 tires. How are you doing that so quickly in your head? Because it's easy, right? It's easy. Essentially what you're doing in your head are proportions.
Well, I said 11.
Yeah, all right. Just stay with us here. If 1 car needs 4 tires, then 100 cars needs 400 tires, right? So you can do that in your head. It's very easy. That's all you're doing here. Stay with me. If 2 moles needs this much energy, then how much energy does 1 mole need? Half of that. Half of that. So when you do these problems, all you're doing is what you just did. There's no other trick. Yes?
I'm confused.
Okay. But hold on. I know what you're going to say and don't say it because you're going to confuse other people. So hold on. I'll come back to that.
Are you sure?
I do know. I do. I'm going to come back to that. If I'm wrong, then you can tell me I'm wrong, but give me a chance here in like 2 minutes. So let's set up a proportion. Let's write this down. So we're dealing with 1 mole of carbon. So even though there's hydrogen gas and C2H4 gas involved, since the question doesn't ask about them, we don't care about them. So we're only focusing here. So here's how we do the proportion. 2 moles of C solid over positive 52.4 kilojoules. So that's my half of my proportion. 2 moles needs 52.4. So 1 mole of carbon needs X. Just like 1 car needs 4 tires, 100 cars would need X. That's another way to explain it. I'd use cars just because it's something easy that you understand. 2 moles of carbon needs 52.4. How do I know that? Table I. And how do I know the 2? It's right here. So this side is just from table I. If 1 mole is reactive, so let's just say we change the 2 to a 1. Yes, I realize that will affect this and this. But I don't care about that because the question doesn't ask about that. So we're just focusing here. If 2 moles needs 52.4, then 1 mole needs X. And you guys already told me it's half. What's half of 52.4? Well, you would cross multiply and divide, and what do you get? 26.2. That is the answer to this question. Positive 26.2.
Why didn't you just?
Yeah, that's what I.
Right, that's what I'm doing.
Yeah, but you did it like way wrong.
Right, because you have to do this method. This is how I want you to show work. You can't ever just do something.
Divided by 2, like.
Right, right. You have to set up proportion. So when you do this homework worksheet, you got to set up a proportion. Because there's going to be problems where this is 1.5 moles. Then you can't just divide by 2. Okay? So you have to set up a proportion. I told my period 2 class, I rarely teach in the way I say you have to do it my way because there's other ways to do things, but I'm telling you on this one, you have to do it this way. Because that way, everybody's on the same page. Because someone will say, I didn't do it that way. I don't want to have to answer all those questions. So do it the exact same way every single time. Moles over heat, moles over heat. Question? You're worried about these 2, aren't you?
Yeah.
Yeah. Ignore them.
Isn't the delta H, isn't that like for the entire equation?
It is.
You're like adding them all together, so why can you just do that to one side and not the others? Like,
You're
why does
doing
that
it.
happen?
You are doing it to the others, but the question isn't asking about that. So if we change this to 1, so if everyone else wants to shut down right now, go ahead. So if this is changed to 1, in reality, in real life, if we want to do this reaction, we would have to change that to a 1, and this to half.
Okay.
So you would have to cut everything else in half. But the question is never going to ask that. It's only going to focus on one part. And I know that's confusing.
But does that mean that the delta H, like, since it's 52.4 right now for the entire thing,
Yep.
does that mean that the delta H for the next one is 26.2?
Yes.
For the entire thing?
Yes, because they would all change accordingly. I know that is confusing. You just have to kind of ignore the other parts, just focus on the question.
Like the other ones weren't changed?
Right. They are, we just didn't address it.
Okay.
Does that help?
Yeah.
Okay. Alright, here we go. Let's do another one. Actually, no, I'll show you the video first. Lights, please. Okay. So this has nothing to do with what we're learning. It's about just moles, not table table I. So I guess it has to do with moles. And this is a mole day video, which is really corny.
I can't wait.
Corny
You're
is.
gonna have Karen saying something from it.
Corny is good.
Yeah.
MC Double T.
So after this video, I'm going to do one more in our notes. We'll do number 1 together on here, and then you're going to finish this for Friday. Then I'm going to hand out this worksheet, and I'll explain what this is about, and then that'll be it for class.
Mole box.
I'll show you the mole box right now.
Roblox? It looks light. Just kidding.
Oh yes.
This is the mole box. It's not very exciting.
There's nothing
Personally, I
inside.
think that's very exciting.
So in this box, there's 1 mole of CO2 and some dead moles. You want to rattle and see if you can hear the bones?
Yes.
Just kidding, that's creepy.
Yeah.
There's nothing in here except air, but the analogy is, in here there's 1 mole of CO2. So what should this box weigh? What's the mass of this? You learned this yesterday.
What's a 10? Yeah. No, it's
No, that's not.
That's how many particles are in here. Good. There's
44.
40, right. So the mass of this box is 44 grams. How many particles are inside the box? 6.022 times 10 to the 23rd. Now the last thing you haven't learned yet, but 1 mole of any gas always occupies the same amount of space, and that's 22.4 liters. So the point of this mole box is it relates moles to grams to particles to liters. So the whole box, everything in this box is equivalent. So 1 mole of CO2 is equivalent to 44 grams, equivalent to that many particles, equivalent to that many liters. This is a makeshift mole box. You can tell I obviously just made it, put it together. You can actually buy these, and they say the same thing. They're just printed. It's like a waste of money. But anyways, it's actually an important concept because you need to understand that this many molecules for CO2 has that mass. We learned that yesterday, that the mass will change, right? So that's why the amount looks like it's different, but it's not. They all have the same number of particles. So there's your mole box. So Kieran is happy, I guess. And this all takes place at STP. So technically, is this room at STP? No, it's at standard pressure. It's not standard temp. What's the temp in this room?
Freezing.
Jeez, I don't have a thermometer
The
on.
temperature in this room is like 70 degrees, let's say, which is like 20-something Celsius, right? It's supposed to be at 0. So for all these things to be true, it has to be 0 degrees Celsius. Okay? So STP is where all this is satisfied. Okay, so there's that. Now the video. We're running out of time here. Again, this is corny, and it's supposed to be played on Mole Day, which is
Last
Saturday
weekend.
or Sunday, right?
No, it was
I
a
know.
while ago. Grandpa.
a lot of kids want to say it's June 2nd. It's not June 2nd because that's 6.02. It's the other part.
Oh, 10.
10:23.
October 23rd is Mole Day.
Oh. That was a while ago.
So why did it take you so long?
Mole Day wasn't in school. It was on the weekend.
How many
So I
weeks
waited
after
till
is this?
I waited till we learned about moles.
What?
Happy Mole Day. same thing as gram forming the mass, so that
Do
makes
you
more
have
sense.
any like normal song videos?
Yeah, I don't make these things.
I see that.
In grams per one mole. How much gas in one mole? That's 22.4. 22.4 liters. Happy mole day to you. Happy mole day to you.
That's you too, not to you, you freaking idiot.
Okay. Hey, relax. So, 22.4 liters in 1 mole is actually something you do need to know. I thought this was funny. I went to this link, and apparently my video is recommended for myself.
Recommended for you.
There you
are.
Oh
You're
my
wearing
God.
the same shirt.
I recorded this morning. That's this morning's video. It's weird how you ever go on YouTube and they recommend videos. They recommended my own video
Never
for me.
recommend my videos.
It's weird. All right, Autumn, you with me? Good. Can you get the lights? All right. Now, go to table I. I'm gonna write a reaction down. Find it on table I, and then I'm gonna write a question, and you're gonna do the same thing with the proportion. Here we go. All right. What do we got? We got enough time? Barely. I tell you what. Let's just do number 1 on the worksheet. We got to move on here. So do number 1 right now. Number 1 on this worksheet. Show me the work either in the margin or on the back. Wait, what? Okay. So use table I. Do number 1 on that worksheet. Given the following reaction, and it gives you CH4 plus 2O2 yields CO2 plus 2H2O. Then the question says, calculate the value of delta H in kilojoules if 3 moles of water are produced. So you're doing the exact same thing we just did on the board, except it's a different reaction. So if you, in your notes, didn't write down the reaction, didn't write down the question, then you have no idea how to do this. Because you're supposed to be using your notes right now to do the exact same thing for number 1. That's what you're supposed to be doing.
Oh my gosh.
First step.
Oh Lord.
Got to give you some hints because some of you are looking at it like it's written in a different language. First step, find the number of moles of water in the given equation. Would anyone like to share with the class how many moles of water in the given equation? 2. There's a 2 in front of H2O. So we know there's 2 moles of water. Next step, go to table I. Find that reaction, look up the value of delta H, write it down. Would anyone like to share with the class the value of delta H? Negative 890.4 kilojoules. So in the given reaction on table I, 2 moles of water are releasing negative 890.4 kilojoules, right? Negative means releasing, exothermic. The question wants to know, what if we have 3 moles of water? How does that change delta H? So we know 2 produces 890.4. I want to know how many kilojoules 3 moles produce. That's where the proportion comes in. That's where the proportion comes in.
Yes.
I am going to go over it with you, but I wanted you to try on your own first. Got an answer, Trevor? Maybe. Adriana, you got an answer?
I do.
You do. Riley, do you have one? Not yet. Amanda, you got one?
Yeah.
Autumn, you got one? Almost. Kristen? Andrew? Still working? Jake? Why not talk to Alexis? Got an answer? Still working? Yes, questions?
Yeah. Why is the heat of the reaction 298? Why is it not 273?
I don't know what you're asking.
For table I, what it says aim reaction at 101.3 kPa and 298 K. Like why is it not 273 Kelvin? Like why is it not? Like if one of those standard pressure reference like the definition.
Oh, because at this reference table, this chart, table I, takes place, you ready for this one? At normal conditions. In chemistry, standard is 273, normal is 298. Just the way it is.
No, why not?
Like a normal person.
Yeah, like 25 Celsius is 298 Kelvin. That's closer to normal than 0. That's freezing.
Or
So,
regular
Well,
conditions.
that's upsetting.
that term is not used.
What about usual?
Also not used. Back to this. If you are confused, please pay attention. If you're not confused, please pay attention anyway. Okay, so how many moles of water do we have? We have 2. So here's how we set up our proportion. 2 moles of H2O. Sometimes I just don't write the word mole because I get lazy, but 2 moles of H2O divided by negative 890.4 kilojoules equals, now I don't know how you learned proportions in the past, but in here we always keep the same unit on top and the same unit on the bottom. That's the only way to do it. But if you put your delta H here and your moles here, then you're flipping your units and that's not correct. So it's moles over delta H. Moles over delta H. The question says, what if we have 3 moles of water? What is the value of delta H? That's how we set up the proportion. So look up here again. The 2 is given to you. Negative 890.4 on table I is given to you. That's the left side of your proportion. 2 over negative 890.4. This is not anything you came up with on your own. Question gives you 3. It says, calculate the value of delta H, that's X, if 3 moles of water are produced. So instead of 2, we have 3. This is how we solve for delta H. Would you expect that number to go up or down? Forget the minus sign, I'm talking about the actual number. Yeah, bigger. Because 3 is bigger than 2, this number should be bigger than 890. Cross multiply. So I get 2x equals, and anyone do write that one down?
Negative 2,671.2.
Okay, negative 2671.2, divide by 2, divide by 2, x equals 1,013 something, right?
1,335.
Negative 1,335.6
That's a small.
kilojoules. That's the answer. Negative 1,335.6 kilojoules.
Yeah, it's smaller, that number. I can tell you.
He said to ignore the negative.
The number itself is bigger. If you start thinking negative positive, you guys are going to get all confused. So in chemistry, you can't have negative heat. Heat is measurable, right? It's particles moving. So why is that negative there? So one reason it's there. Right, just to say that it's being released, it's actually a positive value. That's a number that you can measure. But negatives to tell us it's releasing. So, numbers 2, 3, 4, and 5, due Friday. I want to see the proportion. I want to see the answer. You know, circle it, put a box around it, whatever. So that's going to be due Friday. Now, this is also due Friday, and lucky for you, I put the notes right on front. So read the notes, and then do the back. Good luck with that one, because I didn't explain it at all.
Oh, great. Thanks.
You're welcome. So if you really have a hard time with this, I can't blame you. Just do the best you can, all right?
Great.
I'm not going to, take your head off if you don't have it all done. Just do the best you can. Right, Amber? Always do the best you can.
I have an extra.
That's all I ask. The best you can do. You have an extra. All right. Oh, yeah, calculators. Bring them up. Hey.